Okay, so Kishan, did it? Did you try to do this? And yeah, did you guys finished up your code for pre-order without recursion? I was having some problem in this question for iterative pre-order. It is working for me in Intelibed. Okay, perfect. So my question now to you guys is, which question you want me to discuss now in the class? Do you want me to discuss this like the distance one, like from the source node, the nodes at distance k?
Yes, distance one.
Distance one you want me to discuss? Any other? Okay, Kishan, I will look at the code after the class. Will it be fine? I'll just see it and I'll see why is it not working and I'll give you the suggestions. Okay. Okay, perfect. Then let's quickly start the class. Yeah, I'll try running it in the hacker rank. Then only I'll get to know like what is the problem it is getting now.
I'm also what give a little bit overview on the red black tree, if possible.
Red black tree, I won't give the overview here because it's like if I'll give, then you won't be even looking at that topic after the class ends. So it's like those topics are meant for you to actually do the research first, and then I can give you my suggestions in that. It's basically like you do the study, you explain me what you understood, and if anything you are stuck on some point, then only I can give you the answer to that. Yes. Okay, so let's quickly begin. So what you need to do, the first approach which you can think of is that from the source node, you can find the distance to every other node in a tree. And then what you can do, the nodes which are a distance k from the source node, you can just take its count and return it. Are you guys able to follow this?
So we have to get the count and as well as the data.
No. My point is from the source node, you find out the nodes, like find out the distance of all the nodes which are like in the tree. Okay. So that is what I'm trying to say. You find out the distance to this node, that is one. You find out the distance to this node, it is two. And similarly, you find out the distance from the source node to every other node in a tree. Okay. And then see which nodes are there which are at distance k from the source node. Keep a count of them and then return that count. Are you guys now able to follow it?
Yeah.
Anyone in the class who didn't get this? So you mean we need to keep the count of all the nodes from all the we need to keep the count of all the nodes from the source node, not from all the other nodes. Take source node. Okay, let's suppose your source node is root node. Okay, so from root node, you need to find the distance to all the other nodes in the tree. Are you now able to follow it? Same thing you have to do with the source node. Clear? Okay. But what will be the complexity for this? What will be the complexity for the solution I just said? So n are the number of, you can say, pair of nodes you will get. Then you will follow your classic approach. That is, you will find the distance of the source node from the root node. Then you will find out the distance from the root node till the other node which you are trying to find out. Then plus n to remove the common nodes. Are you guys able to follow this? Yes.
No, no,
Clear, na?
no. Once again, see, from a given node to all the nodes, it will be n times k, because we are traversing k times, and then there are, if I'm going through all the nodes, it will be n times k. I was thinking to find out the count of how many nodes are surrounding one node. So Kishan, in the meanwhile, I know you are not able to send this code or the question, but you can take a screenshot and then
Of
share on
question.
a question. Yeah, which you said that
Let
it
me
was
try sending that.
screenshot would be good.
No,
Yeah.
no, I'll send the link of the code. Let me try.
Okay, okay, okay. So for this, the one which madam was discussing right now, I was thinking from the source, there are n number of nodes which are surrounding, even if it is n, and k is the number of distance, that many steps I have to take. So n into k. Anyone understood why n into 3n?
N is the number of nodes, and
Yeah.
the other one was first N for getting all the pair of nodes which are connected to the source node.
Come again?
We need to find the distance of all the nodes from the source node, right?
Yeah.
So the other N is for that.
Yeah, so n into n. But
Yes, N into N. So the N which is in bracket, first one is for getting the pair of nodes, second one is for finding the pair of nodes from the like kth element, and the other N is for removing the pair of nodes and printing the relevant values.
my job in this just to find the count, not what are the pairs, that I understood.
Okay.
No, if am I
Uh,
is my understanding correct?
yes, yes. See, at the end, you're going to get the complexity of n square, whether you get the count or you print the data.
Yeah, yeah, yeah. But even the intermediate steps like plus n, what was the logic? I mean, intermediate step, how?
Intermediate steps are like the code which you are writing for getting things work. Like first, like after traversing to the node, you're going
Yeah.
to find from the source node what are all the nodes which are connected to all the distances, whether it is 1, 2, 3, 4.
Okay.
First,
Yeah.
and inside that bracket says you are finding the nodes. The second n is saying like you are inserting that node to some other data structure. The third node is saying like you are removing the duplicate element and printing the unique data, or you are printing the kth element of the data. So these are the three ones.
Okay, yeah, I see. Traversing one, and then other one is going to the next, all the surrounding ones.
Yeah.
Ashish, can you give me the host access, please? You are the host right now. I just left the meeting due to some issues. Thank you. I'll just share the screen. Vishnu, did you understood what the question explained to you?
What I understood is, like my question was why there are n plus n plus n. So as I understood is from root to source, it could be up to n. Then surrounding it is n, one more, and then getting the pairs is the third n.
No, the thing is getting the pairs is the first 10. Okay. That is, you're considering every node in your tree as you can say a destination node, right?
Yeah,
And total number of nodes in your tree are n. Clear?
yeah,
Then for all the nodes, what you're doing, you need to find the path, right? You need to find the path from source node to that specific node.
yeah,
So for finding the path, if you remember, we have discussed a solution already, right? That is, you need to find the path from root to the source node. You need to find the path from root to that specific node. And after that, you need to remove the common nodes. At the end, you will get the distance between source node and that specific node. Able to follow? We have already discussed the solution, how to find the path between two nodes, right?
yeah, yeah,
So these two ends are for that. First n is for finding the path from source like root node to source node. Next n is for finding the path from root node to that specific node. And the other n is for removing the common nodes and at the end getting the path.
okay,
Clear?
yeah, yeah,
So this is the time complexity. Next, space complexity. You will be storing the path from root node to source node somewhere. So you will be needing n for that. Again, you will be storing the path from root node till that specific node. So again, you will be needing the space for that. So total space complexity here will be n plus n. Clear, guys? Okay. Right now, I'm not explaining that how you are going to traverse from source node to every other node or how you will find the distance to that. That is your job to do because this is a brute force. This specific solution has came a lot more times. So please try to look into that. Okay. Because these are few things which I can discuss in the class, but it's like if you look into it and then come back to me, you will have a lot more understanding for that specific thing. Clear? Okay, fine. Now this specific solution, if you see overall, it is gonna take n square time. Now we will look into a little simpler solution to it. Okay, so let's take a smaller version of it. Give me a minute. Okay, am I audible, guys?
yes, ma'am.
Okay. So you guys can, I'll just have a smaller version of the tree I had upside. Okay, so if you have your source node over here, let's suppose this is your source node. So how many nodes are there which is at distance? Let's suppose I'm taking k equals to 4. Okay, so if you count here 1, 2, 3, and 4. So I'll just make it other than this, is there any other node on the right hand side of the source node? From the left, we got 1. Is there any from the left hand side? Okay, let me just make one. So this one is also there. 1, 2, 3, 4. Other than this, is there any node which is at distance k from the left hand side or right hand side of the source node? No. Next, we will go a step up here on this node. From here, if you go 1, 2, 3, and 4, this is the place you are getting it, right? We'll get this node. Other than this, is there any other possibility to get? Like from this node to anywhere? From this one step up to anywhere, will we get?
No, no.
No. Now you go one step more up. So 1, 2, 3, 4. You will get it. How should I point it out? Let me just make horizontal lines. You will get this also. Okay. Other than this, is there any other possibility?
No.
No. So we have got basically 3 types of, we get the answers in basically 3 type of ways here. One, you're getting as this. The other types you are getting as and the other ones you are getting as this, right?
Yeah.
So if you see these nodes that you have got, it is directly coming from the source node. That is, you need not look anywhere else. You just go to the left and see the node which is a distance k from here. Then you go to the right of the source node and find out which are the nodes which is at distance k from the source node, right? Can you do that? It is easy, right? You need to simply find a path equals to k, and whatever that node is, you just need to keep a track of that. Next is if you go a step up, that is this one. You will be knowing if you are going a step up that source node is either lying on the left hand side or either lying on the right hand side. There will be 2 cases, right? It can't be the case that the source node is not lying on any of the sides. Getting it? Yes. So if you will, now you will check if this particular node has source node on its right, then you need to look for your answer on the left hand side of it. If this specific node has source node on its left, then you have to look for your answer on the right hand side. Is this statement clear to all?
Yeah. It will be only for level order.
Level order, how does it
You
come
know,
over here?
level means any level which is below that upper node.
Sorry, I'm not clear.
Oh, so for this small rectangle related code, yes, we can go with that.
Mhm.
But this will not apply for any element which is above that.
I'm explaining that, right? Now, when once you are done with this specific node, you are going to go on its left and check how many nodes exist, which is at distance k distance, right? Once you figured it out, now you will go one step more up. This thing you are gonna do until gonna do until your distance from the source node, like the way you are moving up, right? Until this distance is equals to k. Because beyond, like going beyond that doesn't make any sense. Are you guys able to follow it? Yes. So now only one distance is done now. You are going a level up, that is root node. When you moved here, you will check where did your previous node belong to. It belonged to the left hand side, right? It belongs to the left hand side of the root node. Are you guys getting it? So now you have to search for your answer on the right hand side. Does it make sense? And similarly, you have to keep continuing this until all your nodes are covered. Clear? Did you understood the approach which I'm trying to explain here? Yes. Okay. Perfect. So for this, your task will be to find the distance, or basically to find a path from source node to the nodes, which like to a node which is a distance k from the source node above it. Are you getting it? Like not below it, but above it, you need to find a path which is like at distance k or less than that. If you reach the root node, you need to stop. That's it. Are you guys getting it? Basically, you need to find a path. Okay. So I'll just start writing the code here. Will the pseudo code will work, or do you guys want to try it on your own? It's better you, like I can explain you right now because it's little complex in the code. Okay, so for the count function, I'll write here. So you need to check if your k is equal 0. What will you return? Imagine your k is equal 0. What will you return? 1. It means that you have found a node. Okay. If by any chance you have got a null node, what will you do? Either your node is null, source node is null, or by any chance someone has like tried to check whether your code is working fine for the edge test cases and has kept k value less than 0. In that case, what will you do? Return 0. Other than that, what you need to do? What you need to do?
Main logic.
Okay, and what is that?
Traverse in the opposite direction or upper direction.
Okay.
So for that, like, check until the element becomes, or the node becomes null, like node dot left and node dot right becomes null. Keep on going while k is less than or equal to.
It's basically like, see what it will do.
Some temp variable needs to be there to make sure. Temp means step variable, like on which step it is. If it is less than k.
Not clear what you are trying to say.
Yeah. So for traversal, we need to have a counter like step, and that step will increment every time we go away from the source node.
See, count function is basically like, if I've given you a source node and a k, you need to see if there is any node which is a distance k from the source node, right? That simply, this is its task.
Yeah.
K can be any value. You need not bother about right now that, okay, it has to move up, move down, nothing. You have a source node, you have a k value, and you need to see that if the like how many number of nodes are there from that source node. Clear?
Correct. But we need a temp variable to traverse that much distance.
I'll tell you that. But for now, for the count,
Yeah. Got it.
for the count function, you simply need to do what? You need to call s dot left. It's a function where you need not go up and down. Okay, you go to the left, you do k minus minus because one node is already covered. Same thing you do for the right. Not only s dot right, correct, Kishan, it should be s dot left as well, because there are chances you can get something from there. K minus minus. Okay, so when they will traverse, they will find out if there exist nodes from a like at a distance k from the source node. Found, then it will return the answer accordingly. Clear? This is just for counting the nodes. Now coming to the main logic. Okay, let's minimize it. Now we have to write a find path function. Okay, you need to invoke a find path function and you need to find the path. Are you guys able to get this? I am not going to write here how you will find the path or you will find the list or the distance, but you need to find the path. Are you guys clear?
Ma'am, 1 second. I have a small doubt on return count of s dot left and s dot right. Yes, we have taken care of either going left or right, but what about s dot up? Something
I
like that.
said that right now you should not bother about that. And that's what we are going to discuss now. I just said, right, that whatever count function we are writing right now, it is only bothered about how many nodes exist below it, which is at distance k from that specific node. Clear? Okay, fine. So you need to invoke a find path function here, and you need to find a path. Find path from where to where? From source node. So basically, simple thing what you can do, you can find the path from source node, like from source till root node. Okay. So if the distance is longer compared to k, you can just shorten up your distance. Or if it is not, then obviously you know that your answer is going to cross the root node. So you can handle the cases accordingly. Are you getting it?
Ma'am, repeat it once.
My thing is, let's suppose you have source node over here. Okay, this is your root. This is your source node. Your k given to you as 1. Okay, so these will be the two nodes which you will get. This will be the one node which you will get. But when you will find the path, from where to where you are going to find the path? Are you able to get it, what I'm trying to explain? No response, guys. What happened? Vishnu, what's the issue you're facing?
Oh, okay. No, I think I'm clear now. So since k is 1, it is just going top.
The thing is, we just decided that the nodes which are upside to the source node, we will find a path of it from the source node till k distance, right?
Yeah.
But in order to find till k distance, it's little tough. We already have a path, find path function, which finds the path from root node to any specific source node, right?
Yeah.
So you can find that. You can see how many number of nodes are coming up in your list. If you will find it, you will get here source, you will get here x1,
Yeah.
x2, and this is
Root.
x2 and okay. But seeing your k, what is your k equals to?
1.
1. So you will only keep x1 in your list and remove the remaining of them. And you will get your list according to your question. Clear?
Yeah.
If this is clear to you guys, then find path function you can write on your own. I have already told you how to write the find path function, right?
Yeah.
Okay. So after that, what you can do, I'll just quickly write the code here. You will iterate in your list. I'm writing here L dot size. You can manage it. In this, the first thing that you need to do, you know that there can be existing the answer below your source node, right? For that, you can write your answer equals to count of source node and k. Next is you will check here if whatever your L whiteboard is getting stuck. Okay. L of I dot left. I'm just writing here a pseudocode. Okay. This is not a perfect code at all. So please don't follow it. What should I write here? If L of left is equal L of I minus 1, that is, if your current node is lying to like if your source node is lying towards the left side of your current node, then you need to look for an answer on the right hand side. Are you guys able to follow this? This is what it is checking, right? I'll just mention it in a simple way. Let's suppose the above element right now we discussed is x1. If your x1 is lying x1 dot left is equal source node. That means your source node is lying on the left side of x1. This indicates that you need to find your answer on the right hand side. Yes or no? Yes. So here you will call your count function. Answer equals to answer plus count function you will call, and you will pass here your x1 comma, sorry, not x1 dot right comma k minus, what should I place here? K minus minus. Yes, guys, if you're gonna be this much quiet in the class, I can't explain you this tough topic in the class.
Yes, ma'am. K minus minus, because it is decreasing as we go towards the right.
Not k minus minus, because see, you don't know that which node you are currently on. So it's better to write k minus I minus 1. So whatever your ith position will be, it will subtract that from k and minus 1 will be done from that.
Oh,
Clear?
yeah. Yeah.
That's it. In the else block, you can write that you will go on the left hand side, and that's it. Just a minute. How many of you are confused with this approach? Okay. For this, you can. Okay. If those who need to revisit, it's fine. You can revisit it. My question is, if in a simple way you will try to explain this program to anyone, will you be able to do it?
Yeah.
Yes, right? Like it won't be an issue. Visiting a code again, it's not a problem. But the thing that I want you to have is you are able to explain this problem to anyone if someone asks you. Okay, fine. Guys, if you have any doubts in this, you can ask me. Otherwise, we can move ahead. I will wait for some time if you guys have any questions.
Ma'am, again, the question comes back to, we have traversed left and right, but we have not gone up.
Vishnu,
Oh,
the
yeah, find
path,
path. Sorry,
yeah,
find path. Okay.
the path
So,
find. Okay,
mm,
ma, and is it fine now?
yeah, voice is clear.
Okay, previously it was low, so that's why I just confirmed.
Yeah, so
So
find
did you?
path, find path will get me to the upper level, upper right and upper level.
Correct.
Okay.
Now is it fine?
Yeah, yeah.
Okay. Try to do this question today on your own. If you are still stuck, then just let me know. I'll explain you guys. Like I'll tell you guys where you guys are getting stuck. Did anyone looked at the implementation of the min heap? I explained yesterday the insertion, deletion, and getting min. Was anyone able to do that? It's a very simple problem. If you are not able to do this, like min heap implementation is also available. You guys can just visit it. It's very easy. So we can skip that in the, but I know already using priority queue. That's great. So those who is interested in knowing the implementation, they can just go through that once. Okay, and then you can come back to me that okay, we are not able to understand its implementation. I'll explain that. Okay, guys, is it fine? Okay, fine. So I guess we are done with the trees mainly, and there are few problems of the heap which I will like to discuss tomorrow. So I'll just discuss those few questions tomorrow, and then we'll just end the tree topic, and then we'll move on to TP. Okay. Try is a topic which I am like now thinking of taking it in the end. So it will be just kind of an extra topic. Okay. Anyone would like to ask anything? I'll give you 5 or 10 minutes of time. You can ask. Otherwise, I'll just close the call for today. See, bitwise is something which is an important topic. It's not in, you can say extra, but try and miscellaneous will be at the last. Bitwise we will cover after graph. What is the next topic? TP. Yeah, we are left with graph 2. But graph is not that much being asked. We will just cover the basics of graph which is being asked. That is BFS, DFS, some of the known problems of the graph, and that's it. Like graphs won't take that much time. Yeah, and this batch is now mature enough to like handle the topics like that. Okay. What was the question being asked, Kishan, in the graph? Okay. Okay, sure. Okay, then. So I'll just close the call for today, and we'll see you guys tomorrow. Bye-bye. Have a good day.